Okay, the final question, which was called 5.3, but I'm going to change it to 5.2. We've got two countries, north and south. In each country, energy is produced by a coal-fired power plant. Okay, emitting carbon dioxide. And that's raising the temperature. The matrix with coefficients showing the share of total abatement from a country that affects the other country is as follows. So basically, there's a symmetry here, right? It's very straightforward. The pollutant is uniformly mixing, isn't it? And the countries are of equal size, so they're equally affected by each other's pollution. The potential damage reduction in each country. Actually, no, they're not necessarily of equal size, but the pollution flows are equal. It's uniformly mixing, which is true for carbon generally. The potential damage reduction in each country is given by D1 is a half A1 plus a half A2 D2 damage reduction is a half A1 plus A2. Okay. So this is effectively the reduction in actual pollution that occurs. The pollution flows given abatement. I don't really know why we call it damage reduction. The benefits are 500 D1 minus 5 D1 squared in country 1, and for country 2 it's 1000 D2 minus 5 D2 squared. Okay. So this is how much the countries benefit from the lower flows of pollution. These are really the flows of pollution, or the reductions in the flows of pollution. Again, as usual, I would much prefer to see the actual emissions. I'm going to go and close the curtains. Okay, and finally we've got the costs of abatement. I'll put them over here. C1 is 100 A1 plus 10 A1 squared. C2 is 50 A2 plus 25 A2 squared. Okay. So what do we, if they cooperate, what happens? Well, then we want to maximize the sort of total benefits, which is going to be V1 plus V2 minus C1 minus C2, isn't it? And first order conditions in A1. And of course we can't see any A1s and A2s, but I'm being kind of lazy, but V1 is a function of D1 D1 is a function of A1 and A2, so we could write all this stuff out, but I'm just doing it shorthand. So the first order condition in A1 tells us that the V1, the D1, the D1, the A1 plus the V2, the D1, sorry, the D2, the D2, the A1 minus the C1, the A1 equals 0, and this one goes away. So I'm kind of ignoring terms that were 0, and these are the three terms that are not 0. So dV1, the D1 is 500 minus 10 D1, the D1, the A1 is half, the V2, the D2 is 1000 minus 10 D2, the D2, the A1 is of course half, and that should all be equal to the C1, the A1, which is 100 plus 20 A1. And of course we can wipe these halves and say 200 plus 40 A1. Okay. And the first order condition in A2 is going to be being lazy, the V1, the D1, the D1 by the A2, the V2, the D2, the D2, the A2 is equal to the C2, the A2. And then we get 500 minus 10 D1 times the D1, the A2, which is half, so that's 500 minus 10 D1 times a half. Let's just keep that half in our minds. The V2, the D2 is 1000 minus 10 D2 times a half, the D2 by the A2 is equal to the C2 by the A2, which is 50 plus 50 A2. And then we've got this half, we're multiplying through by 2, so it's 100 plus 100 A2. Yeah, we're getting there. Those are our two first order conditions. They're going to be pretty straightforward to simplify. We'll go over here. So what have we got? We've got 1,500 minus 200. 1,300 is equal to, aha, yeah, we've got these D's to sort out as well, yeah. Okay, 40 A1 plus 10 D1. 10 D1 is 5 A1, isn't it? So that's 45. A1 plus 10 D2, that's another 5 A1, so that's 50 A1. 1300 is 50 A1. And then 10 D1 plus 10 D2, that's 5 A2 plus 5 A2, that's another 10 A2. Of course, you should take, if you imagine being in an exam or something, you should be taking more care than this. You've seen me making mistakes several times already. Let's see, here we've got 1500, 1400 equals 100 A2 plus 10 D1 plus D2, so that's plus 10 A1 plus 10 A2, so that's 10 A1 plus 110 A2. Okie dokie. So let's divide everything by 10. Actually, let's not. Because I want to divide this lot by 5 to get 10A1 plus 2A2, 5's into 130, go 10, 20, 26, so that's 260. So we've got those two equations. So now we can subtract the top one from the bottom one, and we get 1,140. I believe that goes away. Is 108 A2. A2 is 1140 over 108. And a quick pause. Okay, I just checked my crib sheet. This is all looking pretty good. So according to the crib sheet, A2 should be 10.56. A1, of course we can put this back anywhere, like here, to get A1. So this is like 21, take that over, you've got 239 divided by 10, it should be 23.9, and it is 23.89 according to the crib sheet. And we can put those back into the profit function. What's the benefit function here? It's going to be a bit of work, but we're going to end up then with I1 is minus 968, and pi 2 is 12,426. Whoa! So country 1 is not very happy here. Why is that? Yeah, so country 2 has a lot of costs. Yeah, country 2 has got this steep increase in costs, which is going to keep its abatement down in the optimum. Yeah, because of the steeply increasing marginal costs, 25A2 on the margin. It's going to keep its total abatement down, but at the same time, it has bigger benefits. But the key thing driving this seems to be that it has much lower costs. Yeah. So 25 times 10 squared, see 10 squared is 100. 25 times 100 is 2,500. But 10 times 24 squared, 24 squared is like 5 500, isn't it? (24 squared). It's about 500, I think, yeah. More than 500 times 10, so that's like 5,000. And then here we've got 100 times that, that's another 2,000. So we've got higher abatement, much higher abatement here, giving much higher costs. And then lower benefits in country one. Yeah. So it's all stacked against country one here. Okay, back to it on the home stretch. Let's have a look at the question. Determine optimal allocation in the two countries in a cooperative scenario and net benefits for each country under cooperation. So that's this. Part B, determine optimal allocation in the two countries in a non-cooperative scenario. Okay. So if we focus on country one's problem is to maximize V1 minus C1, isn't it? With respect, and given its choice variable, which is A1. So, first order condition in A1, dV1, dD1, dD1, dA1, plus, nope, this one drops out, equals dC1, dA1, right? And dC1, dA1, yeah. So we've got a half times 500 minus 10 D1. This one disappears, and that one is still there. So that's our answer. For country 2, we've got V2 minus C2, and it's dV2, D2, D2, D8, 2 minus dC2, dA2, dV2 by dT2 is 1,000 minus 10 D2. That one's disappeared. Don't need those brackets. Is equal to, and times a half, is equal to dC2 by A2, which is 50 plus 50 A2 and a half, times both sides by 2, we end up with that. Okay, so those are our equations. Coming back over here, we've got, take the 200 over, we've got 700 equals 40A1 plus 10D1. So that's 45A1 plus 5A2. And here we've got 900 equals 100A2 plus 10D2, so that's 5A1 plus 105A2. Okie dokie. So, how are we going to deal with this in a nice easy way? Why don't we just hit it with a sledgehammer and multiply this by 9? So 9 nines are 81, so that's 8,100. It's 45 A1 plus 900. 5 nines are 45. 945 A2. So that gives rise to that, I believe, with a bit of luck. So now we can get rid of A1, we subtract the top one from this one, and we have 7,400, 0, 940, A2. We can wipe a 0 straight away. So A2 is 740 over 94. And it's time to look at my crib sheet, which says that A2 should be slightly more than 8. 8 nines, 9 eights, 72, 720, 8 fours. No, so this would be slightly less than 8. Oh, I think I got something wrong. I'll try and sort it out. Okay, I found one mistake. Let's see if there are any others. So this is 900, that's right, but 500 minus 200 should be 300. So 8,100 minus 300, 7,800. Oh, this is looking much better. So then it's 780 once we divide it by 10. And this is looking so much better. Because that looks very like 8.3 to me. A2 is 8.3. Given that A2 is 8.3, what's A1? Well, 5 times 8.3 is 41.5, so that's 341.5 divided by 45 is going to be about 7.5, isn't it? No. Okay. Oh, sorry, yeah, I lost the minus sign again, same problem as I have here. This is, what did I say, 41.5, subtract from this, it's like 259, which is 5.5-ish, times 45, or to be more exact, 5.74 times 45. And we get pi 1 is 2360, pi 2 is 4639. So clearly here, country 1 is not keen on a cooperative solution unless there are like side payments or whatever. Country 1 is never going to agree to this. Sorry, country 2 is never going to agree. Oh, I'll get there in the end. This one is the cooperative one. Country 1 is never going to agree to the cooperative solution unless country 2 is willing to make some pretty substantial side payments. Country 1 basically has lower benefits and also ends up bearing a bigger proportion of the abatement costs. Ironically, because of the lower marginal abatement costs or the flatter curve. Okay.
So, oh, wow, spent a long time on this. Okay, it's high time we rounded off this question. Part D is super straightforward, right? You just got to look at the difference between these two. This is non-cooperative, yeah, so for country one to agree to go from here to here, it's going to want payment equal to this difference, which is like $3,300 or whatever. And of course it would be delighted to take more, and conceivably country two would still be happy to switch from here to here, even if it had to pay like $7,700, losing, if it's going to lose $7,700 of this surplus, it's still going to be better off than it was here. So in theory, you could have a transfer of up to $7,788, according to my crib sheet. And that is the end of the final question.